Hello, everyone. Welcome to the wasmCloud community meeting for Wednesday, January 31st. I think we go ahead and kick this thing off with take a look at our new wasmCloud homepage. Look at how cool this looks. Um, Huge shout out to Nick for putting in this PR. A little earlier today, we showed it off a little bit in a an earlier community meeting. But if you come to the page, then you get this nice little cloud bouncy animation that may or may not have translated well to the live stream, and all of the value props and features that you know and love, but with really nice design, really cool diagrams. We've been kind of rolling with our set of diagrams for quite a while. So I just want to give a huge shout out and to Nick there. Not only is this like revamping kind of the homepage, and it also has like little dark mode diagrams as well. This kind of does update. It's a little bit easier, shield your eyes, to see in the rest of the documentation too. Just kind of some emphasized elements around like bold elements and like the division between the top. Just kind of an overall huge improvement for the site. So thank you so much. And go check it out for yourself. This is live on wasmcloud.com. Okay, so without more geeking out on that, though, I do love it. Um, the community meeting today should be really fun. I've updated a couple pieces which may come in a little bit later. We're going to have a couple really fun discussion items, but to start, we actually have Stuart Harris and Victor coming from Red Badger doing a demo of wasmCloud running composed wasm components. So I'm super excited for this. I don't know what it's going to look like. So I'm going to go ahead and turn it over to them to just go ahead and show us.
Thanks. Hi, everyone. I'm Victor. This is Stu. We're sort of sitting next to each other, but trying to make it look like we're not. We have been working on a sort of a proof of concept for ourselves to do a comparison of what WebAssembly-based platforms are like compared to like current cloud platforms like Kubernetes and Friends. And as part of it, we've been playing with WebAssembly component compositions. Do you want to give any more context around that, or should we jump in? But how do you want to play it?
We have a bunch of clients that are big banks, and they do typical big banky kind of things, which is, Java, Spring Boot, and Kubernetes. And so we wanted to do a proof of concept that does like the typical stack that a bank might choose today versus exactly the same thing, but instead of Java, Spring Boot, use Rust, and then a completely different thing instead of containers, use WebAssembly, and deploy that WebAssembly to multiple different platforms to demonstrate the portability of it. And we want to be able to measure the difference between each of those in terms of the sustainability angle. So how much energy does it consume? How much effort is it to build? How much resource does it consume, basically? And how much does it cost overall to run? And to measure all that and write it all up. The Rust Foundation are interested in it from the Rust angle. Open UK in the UK is an open source sort of quasi governmental body which is interested in it from a sustainability angle. We're interested in it from a consultancy because we want to prepare some of our clients who are building greenfield applications so that they can deploy them to next gen platform. So that's where we are. But so it's all very proof of concept. It's all very noddy, we say here. I don't know.
Yeah, we're nowhere near done with having it all complete. But I'm going to share my screen, show you sort of an overview of what we're going for. So this is just a diagram we drew for ourselves to sort of orient ourselves around what we're doing. It's based on some example that we found for Java, Spring Boot, and microservices, and we thought that's a decent, reasonably complex microservices platform application shape. So let's replicate that in the two more modern ways. And so far, we've built this little vertical of products. which is a nice independent service. Its job is to store a product catalog. It's possible to add products, and it lists products. And in WebAssembly, we wanted to try and see what it would look like if we used component composition to do sort of like adapters from something that is entirely portable and completely devoid of any sort of platform dependence to something that can then run in a platform. So we've got this inner products component, which has no idea that it is running as a HTTP server. It's just a service that can, given a key value store of a particular shape, it can surface products that are stored in the store, and it can add products into the store. So we can look at what that looks like in WIT. Presumably, since WASI is now 0.2, everyone's ready to read WITs, right? That's a sensible assumption. Okay, so we've got, this is our own WIT interface called products. Down here, that's the service that we're talking about. Ignore this, that's just an overhang from some previous thing. And we work with these product types. They have an ID, name, description, price, and SKU code. We also know some errors. And what we can do is create a product, which given a product gives a result, either it succeeded or not. And we can list all the products that we have in the inventory. So that's the basic building block. So then we've got code that implements that, where its own world as a product service says, I provide this product interface and I require a key value interface. This is, again, our own key value interface, and this is only because we looked at how much of WASI key value is sort of ready, and it isn't quite for what we needed for the listing. So we've defined our own that is sort of hacked on top of the existing one. So if we look at what that looks like, it knows sort of about buckets. It can get all the keys in a bucket, get back a list of sort of key value pairs, and it can set a key to a value, which is all we need for this particular service. And so we have this product component, and then the piece that we were looking at above that, this HTTP to products, is an adapter that exposes that component. Oh, sorry, I'm always in the wrong one. That's the one. Products HTTP has its own WIT, which imports the product interface we were just looking at, and exports a WASI HTTP incoming handler, which is something wasmCloud understands. So the remaining piece of it is, how do we adapt the key value interface that we just looked at to wasmCloud supported WASI key value? And we've got this platform wasmCloud component, which will eventually do a few more protocols, which does exactly that. It imports WASI key value read write, and it provides key value. So we've got these three components as individual pieces. They build using cargo components. They're all built in Rust, but it's not really that important, I think. The really fun bit of this is this configuration for Wasm Compose from Wasm Tools, which we point at the HTTP component, the products HTTP, and say for the import of products, use the product Wasm module from the product target directory, so wasm32 WASI. So use that as the provider of the products interface. Use this platform wasmCloud as the provider of the key value interface, and produce a component which goes into this build directory. So if we go and look at that, how do I hide this panel? It's always, anyway, compose, build. There is the wasmCloud at Wasm, and we should be able to do wash inspect with exactly that. There's lots of imports because it's a WASI target, but off the platform one, there is only this types one. I think that's a bit of a bug that we need to fix. But other than that, it's not talking about the products interface at all, or our own key value interface. It's all in terms of WASI. And so we should be able to run that on wasmCloud. In order to do that, we've got a WADM spec, which reads that component from a file. There is a mid step in between where we have to sign the component. That's what the _s is. And all we want for it is a link to a HTTP server and a link to Redis key value store using these two capabilities. And that should all work. So here is the fun part of the demo, I hope. How can I get rid of this so that I can see things? Do you have any idea how to hide this?
You can grab it anyway.
Oh, is it the Zoom handle?
Move it if you click down. There's a little like on the far right, there's a little down button, so you can slide. It'll move it to the bottom of the screen.
Oh, it's yeah. I think I've managed. So I've got this wasmCloud UI running. At the minute, there is no wasmCloud instance, so it's all red. So let's go start it. There we go. So if we go back, we should see a host soon. Oh, there's two of them. One is probably some previous attempt, and nothing's running on it so far. The other thing I've got running is Redis down here, and then the UI. So I should be able to go in here and say, and now this thing is in the way again. Wash app. I mean, just to prove it, if I do this, there's nothing there. Deploy. And things are starting to happen. And if we go back here, we should slowly start seeing this all come to life. I hope. Fingers crossed. And eventually we should be able to call this. Not yet, let me see. This might take a little while before it gets there. Should have really prepared it running. Oh, here we go. Host is just one. There's one component. Providers should start up soon. Trying to think what else is interesting about this while it's starting up. Happy to take questions if you have any.
The thought was that we would compose our components in different ways for different scenarios. So
I guess that's this bit.
there'd be a composition for wasmCloud, which did that, the translation to the wasmKV. Maybe a composition for Fermion Spin or something we haven't done yet, which maybe uses the Fermion SDK directly or something, but
or their own WASI interface, or not WASI, WIT interfaces.
But the internal components effectively would be exactly the same.
This happening?
What have we done wrong here?
Yeah, this is a very good question. What have we
Oh,
done?
there we go.
Oh, there we go. Maybe I just needed to refresh. There we go. That's running. How about the link definitions? Do we have them? Yes, we do. Sorry, I've got the panel in the way, so I never know. Okay, and here is an API. Hooray, it runs. What we can do is post the product there. There's one. That succeeded. So we should now, lovely. And I guess just to prove that it is genuinely using the Redis, I'm going to stop that Redis server and try to post it again. And you can see that I'm getting an internal server error, which is a store error, which is a key value store error, internal, blah, blah, blah. It just propagated all the way through. And if I try and run this, I get nothing. I think just because somewhere we default to an empty list. If I bring that back up, if it managed to save, it didn't. Oh, no, it did. There it is. It's back in. Yeah, I think that's it, really. Yeah. I'm happy to answer any questions you might have.
Yeah, hey, it's me.
Hello.
Audience plant. I do have so I know that you know, this whole demo is like compose components, right? And you know, at the end of the day, you're interacting with stuff that like wasmCloud and any wasm component runtime will understand, like WASI key value, WASI HTTP, all that stuff. But so you or when you're writing the component, though, it's all in terms of that like platform interface. So you're not actually, you get to interact with your own interface, and then you're composing a component with that to do the like kind of translate between those two. Is that how it works?
Yeah. And that's possibly a little bit overkill. I guess in real life you might write to WASI interfaces directly, but we just wanted to show that this is possible, right? That you could write the components as pure business logic and adapt them to different incoming interfaces. You could imagine that service responding on NATs instead of HTTP in a similar sort of fashion.
I think we wanted to adapt from the platform-specific interfaces to domain-specific interfaces as quickly as possible, or as close to the edge as possible, so that all the bits in the middle are domain-specific and don't have any knowledge of platform.
Oh, I just remembered a second reason. Hang on, if I share my screen one more time. In the example, there is one case where the services talk to one another, which is this orders and inventory. We haven't quite built that, but one of the thoughts we had is that in wasmCloud, we're going to run these as separate actors, 3 separate services that talk over the lattice to one another as independent running services. But in something like Spin, we will actually compose them all together into a monolith that just runs all 3 services in one, hopefully without changing the services. So instead of orders talking to inventory through some adapter that does network communication, it will just bind to the inventory's interface directly. We haven't got that working yet, but that's one of the things that we wanted to do.
It occurred to us that there's actually 3 different ways that that order service can speak to the inventory service. One is directly through WIT and as a composed modular monolith, effectively. Second is actor to actor inside wasmCloud, and third is like via HTTP. So each time sort of like coming out a little bit further. But yeah, I mean, we're really interested to see what the performance characteristics of like in a serverless environment, for instance, spinning up effectively the whole modular monolith to service a request, and then letting it die after the request is finished, because at the end of the day, the instantiation cost is minimal, and we still get all the modularity and independent deployability of each component.
Yeah, one of the things on my mental to-do list is to implement this blue arrow such that orders imports the inventory interface, even if we're doing the network hop, by making a sort of a component in between, which exports inventory on one side, and then imports it on the other.
Yeah.
And binding, and in the middle does network communication, and then binding that to either side of any of them or something like that. Just adapting
middleware,
like a middleware sort of thing between the things, so that the orders component doesn't need to know that there is or isn't a network hop in between. We'll see whether that works. That's one of the sort of ideas that we would like to sort of show, that some of those components don't need to change and they all like plug in together like Legos. And if they need to communicate differently, then that's just different kinds of Legos in between.
One of the things that's super fascinating, we're out at the Bytecode Alliance Plumber Summit today. It's streaming live on YouTube. But this morning, part of the discussion, went across WRPC, which is actually on the agenda for discussion later today, and that's actually just now been rolled into Wasm tools. So the WRPC, it looks like it's actually not just going to be a wasmCloud thing. That's going to be a general tool and standard that could be useful across all of WebAssembly. So I think that's incredible. So we'll have a protocol that gives us native WIT-to-WIT communications that works across HTTP. And I think that will be a real superpower that everybody can use. And of course, it should be baked into wasmCloud by default first, because that's what our real use case is. My understanding is, and I think next week, if you have questions, Roman and Bailey should really speak to this, is that we've already got the tricky bits baked into Wasm time. So it's at this point, it's a matter of documenting. I'm also pleased to let everybody know that the most important piece, which is obviously the naming and the domain and the GitHub, repo, is that we were able to acquire WRPC.io, which is a maze, as well as the WRPC GitHub project domain, thanks to one of our incredible community members, Iceberg. Iceberg, I know that you always watch. Thank you so much for that. So when we get the standard documented, we will get it launched, and it should have its own nice landing page that describes the value props and should have its own life to sort of describe it independent of wasmCloud. And my hope is that in the same way that we've kind of seen, wasm and WRPC, our old protocols kind of get adopted by a bunch of different projects and kind of take on a life of its own. That WRPC will sort of become our new seed that a lot of people go out and build WebAssembly projects on top of. I think it's got the kind of legs and the vision for that. That when people look around and they're like, oh, I need something that gives me native wit to wit, that it's going to be what they look at first because it's there. And in fact, some of the other startups that are here at the Plumber Summit, like immediately went to Roman and they're like, hi. I've been commenting on your pull requests, and Roman's like, "Oh wow!" He's like, "So funny that you're here." I'm like, "That's not really a surprise." So it's been good.
Yeah, I'm really excited, Victor and Stuart. Like with this demo, I think you can really start to see some of the vision that we're talking about, and we'll talk a little in this community call about it too, about the links with WRPC, because like what that one orders microservice, the component may import a function from inventory, and if you want to compose those together and then just run the whole thing, then that's great. The whole vision for wasmCloud is that if you didn't want to compose those together as one component, then you run the inventory and you run the orders, and then that import export pair, instead of being composed together, is just distributed over the lattice, and that is just the way that it works. That is the whole goal of the WRPC linking proposal.
That's amazing.
Right, yeah, like dynamic linking instead of static linking.
Yeah, that's a great way to put it. I really like that. Okay, I think I've monopolized too much of the time. Do other folks have questions for our wonderful demoers?
Finished, we'll
Sorry,
demo it
go again. I was on mute.
I was going to say when we've finished it, we'll demo it again. Maybe it'll be a bit more interesting.
Yeah, the other thing we will do when it's a bit more stable is open source it. At the minute, the repo is private, but there's nothing really stopping it being public. It's just a bit of a mess.
I can tell you that I'm literally in a room full of, well, everybody's at lunch right now. But like everybody here would love to see this. Do you want me to point this out to people like in the room, or like preview it, or wait till you guys do the full release?
I mean, we can just open source it tonight, really.
Yeah.
It's just a bit noddy. We can make it public
now,
and then you can point it out to people. It's fine.
Okay. Yeah. I mean, I'd love to just, yeah, I'll just link them.
them.
I'll just link them to the community call, like recursively, like they can, go back like 20 minutes and start playing it, and then they'll catch up to like what's happening now, and it'll be on the big screen. We'll have like a whole Spaceballs moment.
Excellent.
Yeah.
Just
there's
doing
no
it.
README. We'll add it over the next few days. But I'll change visibility, change the public.
Do no pressure. If you need to, check it for secrets and, passwords and, all that kind of stuff. Like, I don't think there's, we're at the summit tomorrow. I could like let people, I could point them at it tomorrow if you want. You don't have to do it right this second.
So this is the root doesn't have a README, but this does. So I'm just putting it.
It's done.
There it is.
Hopefully, you should be all able to see it.
If you see these secrets, they won't mean anything anyway. There's no restrictions. I don't think they're wrong.
Hopefully, no. What could go wrong?
Thank you.
Okay,
Thank you all
great.
for sending that. That is huge. Um, Reminds me of like Carl Sever's talk at Wasm Day when he'd been working on a project like in stealth mode, and on stage he's like, "Okay, I want you all to be able to play with it. I'm going to change this repo from private to public." Ooh, this is going to be a really interesting repo. You've got like Java container stuff in here too. So you're going to do like the full comparison.
Exactly.
Yeah, that's the idea.
Yeah.
Once we get there, I think that requires some like privately provisioned infrastructure that someone would have to replicate to make it work. But Terraform is in there somewhere.
Yeah.
Nice.
And it's not the cleanest of things, but it wasn't intended to be. It's just like thrown together. This is typical Java. This is typical Rust with containers, and then this is the stuff side by side, same functionality.
All right, folks. Well, thank you so much for coming on and doing the demo today. As the project evolves and you have more things you want to demo, please let me know. Happy to throw you up on the agenda to demo. Or even if you hit like a sticking point or something in wasmCloud, you're like, hey, I wish we could do this. Let us know.
Yeah, definitely. Thank you.
Thanks.
Oh, I would just say one more thing on that. I saw like, right when you deployed the application a little bit earlier that, you were looking at it and waiting, and maybe it was just like a page refresh thing, but I did see that like the provider stuck around, like didn't do anything for a little bit, and then both of them launched like immediately. Um, I think we go back and take a look at the recording, see if that was just something that Wadham was slow from looking at state from a previous deploy or something like that. Because it seemed a little unusual. That's not normally what I see.
It definitely was. It is normally much quicker and more responsive. I've been like deploying and undeploying that thing quite a bit, so it might be some just inconsistency of that abuse. It normally works much better.
Yeah, if you find out more information there too, feel free to send it my way. Alrighty. Well, thank you guys again. I really appreciate it. It's a really fun demo. Um, Okay, moving on. I did change the agenda a little bit in stealth mode, which is pretty fun. But we've got a couple discussions and updates from now until the end of the call. I believe last week we were sitting here saying, hey, WASI Preview 2 should be launching pretty soon. They're going to vote on it tomorrow, being last Thursday. And, hopefully it works and that'll be really cool. And I just want to give a formal congratulations to all the folks in the WebAssembly organization, all the Bytecode Alliance, all the WASM working group people, and just say congrats on launching WASI Preview 2. Really exciting evolution in server-side standards for WebAssembly. If you are wondering what this means or what to expect for wasmCloud, I did put out a small blog called WASI 0.2 and why it matters. I tried to keep this one kind of short and simple, and there really isn't too much here that talks about like wasmCloud in depth or things of that nature. It really does kind of focus on some of the experience that I've had with writing like basic Hello World apps, and then going on from there. Kind of what the future of what this means, like why this is important. If you take a look at WASI Preview 2, the interfaces that are a part of the proposal that the WASM working group or the WASI working group voted and as a part of Preview 2. There's I/O, clocks, random file system, sockets, CLI, and HTTP. And you can kind of see in these are all links. I guess I'll go ahead and send it in the chat as well. All of these are included in WASI Preview 2. And so essentially wasmCloud will, for all of these interfaces, support the 0.2 version of this. And what that means is if you build an application using, whatever set of tooling, if its set of imports and exports are part of this set of APIs, then It'll work out of the box in wasmCloud. It will work in something like wasm which is a little more geared at the HTTP world. And it should be great. So, this little snippet of code up here, which is exactly what our kind of hello world, like hello from Rust example is. This will work right out of the box with wasm. And another thing that this blog touches on just a little bit is that the fact that those interfaces are standard and common doesn't just mean that you can run this component in wasmCloud and you can run it in wasmTime, for example. What it really means is that library implementers in each language can start to work on their WASI target in terms of compiling down their library into the primitives that WASI Preview 2 provides. So what we're really working towards is a world where this is the and I don't have a relationship with the folks who maintain Rocket. It was one of the cool, simple hello world type things that I found. But this is a piece of Rust code that uses a crate called Rocket to serve an HTTP endpoint. And the ideal here is that using a library like this, a crate like or a library like Rocket could compile this down to the WASI HTTP interface, and then you can run this component out of the box. There is no interaction with there's no needed interaction with WIT, for example, or WASI interfaces. This is kind of the end goal that we are chasing. It's like direct integration with standard libraries and community libraries. So we're working towards that. I'm really excited. I think that the first example of that is going to come out sooner than you expect. Something like in the next coming weeks. That's not like I'm not saying that that is what we're doing. I'm saying that it'll be really cool. An example of this will probably come out really soon. And moving on from that a little bit, I do want to just call out that with all of the component examples and the tooling in the Bytecode Alliance, we have been able to upgrade our wasmCloud intro, like our quick start, to support, well, infrastructure-wise, we support local and Docker, but you'll see a bunch of languages now. So you can actually run through the quick start in wasmCloud with Rust, TinyGo, TypeScript, or Python. And TypeScript has actually just a little bit of a layer that transpiles from TypeScript to JavaScript, so you can extend kind of the same thing for JavaScript as well. So I want to give a huge thanks to the folks in the Bytecode Alliance who are working on Componentize.js, which is how we can have JavaScript support, and Componentize.py, which is how we can have Python support. But this is kind of the utopian future we've been discussing for a little while now, where when we have standard WASI interfaces, we get a lot of portability between runtimes. We get a lot of flexibility to support different languages. And it is just kind of overall a really exciting time to be working in WebAssembly components. So wanted to call attention to all of that. And yeah, any questions regarding WASI Preview 2 or what wasmCloud is doing with it? All right, very cool. Speaking of WASI Preview 2 and the Bytecode Alliance and all that fun stuff, Liam did kind of tease this a little bit earlier, but after you hop off of the wasmCloud community call, you can go over to the Bytecode Alliance YouTube. They're actually streaming their summit right now, where they're talking about things that they want to implement in the future, things like WASI Preview 3. A lot of cool discussion. I kind of have it on my other monitor for a little while now. I'm not watching it right now. That would be ridiculous. So check that out. Okay, then I think what we can do for the rest of the call is just do our regularly scheduled roadmap update. There has been a lot that changed since the last time we touched in. or touch base checked in. That's how that works. So if you take a look at the wasmCloud roadmap, this is just on the GitHub org page. It's one of the only ones that we maintain regularly. But on the 1.0 milestone, you'll see that everything looks a lot thinner, and it doesn't exactly mean that we've done a ton of, it's not like we've closed out 5 epics, but I do want to call attention that more things have moved to completed. And we're still continuing to make great progress on our WIT interfaces and moving those to the and only using WIT interfaces and host metrics. This one is actually technically in progress. Taylor Thomas, who's a wasmCloud maintainer, he's here all the time. You know Taylor is working on finalizing this RFC, the formalize the wasmCloud control interface. So this is going to be just taking our control interface protocol, standardizing the topics. It sounds kind of boring, but it does enable us to do cool tooling things around watching traffic over a control interface and things like that. Now, I want to call attention, maybe the last time we were on the call, there were 10 or so blocked tickets, and there's a lot less now. And that is because we've been able to close, I believe it was 4, it might be 5 really high effort RFCs. And essentially, all of those RFCs that we were able to close encapsulated a piece of functionality that we were looking to design around in the current wasmCloud system. Now, all of those concerns, some of which being things like I want multiple versions of a component to be able to exist at the same time so that I can do things like A/B testing, zero downtime upgrades. I want to be able to link explicitly to from an actor component to another actor component, both for access control and configuration and routing things. There are 2 more that are kind of escaping my mind. I think it's version or interface specific links. All of those are actually encapsulated in this one RFC called componentizing links with WRPC. And it's a little bit of a marketing-y title, but I couldn't think of a better way to propose this to folks. We have the proposal for WRPC, kind of the protocol, and this is how this protocol affects wasmCloud. So this is going to be the largest piece of work that we're doing moving to 1.0. But don't let that discourage you. This actually is mostly rearranging information that we already have. Some of the key pieces in here, Victor and Stuart, this is what we were talking about earlier as the way that we want components to interact with each other over the lattice. Big things that are going to change here is the fact that links are now going to be unidirectional. So they have some kind of directionality to them instead of, you say, hey, link this component to the HTTP server. What you're going to say is, hey, link this component's incoming handler so that the HTTP server can call it. So you don't get bidirectional communication. That I think works a lot better for access control, and it lets you have a kind of specificity to the interfaces that you're linking up, which you will definitely need with WASI. I mean, all the WASI calls that you're making are either exports or imports, and so we'll essentially follow that convention. Other than that, we are also going to be including, and it may be slightly separate format than this. Here, let me zoom in. But we're going to include WASI interface information on the link. So links will be kind of specific. Instead of using wasmCloud specific contracts, we will be using WASI interfaces, whether that's something custom that you've built or a standard, which will be great. It just kind of doubles down our commitment there to the component model. And so that kind of removes a little bit of an impedance mismatch with wasmCloud contracts and WASI interfaces. We're also removing a somewhat point of confusion that wasn't commonly needed, which is capability providers running on a link name. Now you can use link names to address different versions or different instances of a capability provider, which will be great. And other than that, there are a couple pieces in this proposal around static configuration, and what it'll look like in like a WADM manifest for you to specify this component. But all in all, what this really does is gives a better method of natively supporting WebAssembly components in the wasmCloud ecosystem, and should be a really exciting evolution. With all of this, we are not taking away any functionality. That the things that you can do in wasmCloud now with wasmCloud contracts and the lattice and provider components that are like native binaries, all of those things are getting carried over in one form or another with this model. And I think there's also some other pieces in here that are really cool around, possible ways to support like end-to-end encryption of workloads over the lattice and things like that. So there is a bunch in here. This is a really long RFC. Please feel free to ask any questions if you have them now, or in Slack afterwards once you get a little bit of time to grok it. But the TLDR here really is that we want it so that when you run a component in wasmCloud, it feels like you're composing them at runtime dynamically over the NATS network. And that's kind of our North Star there. Should be pretty fun. Okay, folks. That was kind of a lot of talking there, but that was the end of our scheduled discussion. Does anybody have any questions on the last part there, or just in general? Cool, cool. Well, then I think we are I think we're at the end of the call here. We've got a couple more minutes, so I will leave it to a little bit of silence. If anybody has other questions or things that they'd like to discuss from just broader wasmCloud ecosystem or broader WebAssembly ecosystem, please feel free to just go ahead and raise your hand and ask the question. All right, folks. I think that'll do it then. Again, shout out to the Bytecode Alliance community stream. If you're interested in taking a look at some of the behind the scenes design work, they're live streaming today. But other than that, I think we'll say goodbye to January and for today, and we'll see you all next week on